Let's go through LeetCode 1157 online majority element in subarray. So let's design a data structure that efficiently finds the majority element of a given subarray. So we need to implement query left, right, and threshold. The majority element of a subarray is element occurs um, at least the threshold times in this kind of subarray that is from the left and the right inclusive. And then this query, because that is because we want to it is online, so left right it will be changed. So we know for the majority element, right? So we have the way like the more voting, but the thing is that the more voting it is still all length, time complexity. So every query, if we do more voting from left to right, apparently it's not efficient, right? So for this question, actually, we can do something called a random sampling, or it is called a Monte Carlo simulation or Monte Carlo approximation. We call this method random sampling. What does this method do? Is that we are trying to find the majority of this range, right? So we just do 10 times, for example, 10 times, um, 10 times the query from the left to right. And what we do is that we search um, we pick a random number from the left to right, right, and find this number in this array. And in this array, we already pre-compute its indexes, right? So we just from these indexes we can do binary search to find how many counts for this kind of number. So if we simulate it 10 times, right? And if we find a number which is greater than the majority, then we return the result. Because if there exists a number that is greater than majority, that means it have 50 more than 50% of the probability to be chosen. So if we do 10 to 10 times, the chance we are not able to find the majority number is 10 to the uh, 2 to the power 10 minus 2 to the power 2 to the power minus 10 chance that is not being found, right? So doing like this kind of simulation, we can do some kind of efficient way to find this kind of element, given the left and right are change frequently. So let's write code for this, right? So what we need is that we need a preparations, use a map and list as integer as the index. So what this map do is that we are going to for every for to store the indexes to this map. For example, for example we have for example this kind of 1 1 right? So we have the map have two entries, 1 and 2. The key will be 1 and 2, right? So the 1 appears in index 0, 1, 4, 5, right? So it will list 0, 1, 4, 5. And 2 have a key, have index 2 and 3, right? So it will have two entries of that. So, and also, we can put this array out. Right? So what we do is that we're going to have this array equals array, and the map equals new hash map. So let's do preparations um to put the index into a map, right? So for int I equals 0, I smaller than array dot length I plus plus Then what we're going to do is that we have map compute effect sense. So we have array I k goes to new array list f I, right? So for every number, we just have the list of its indexes. So for every query, what we do is that we just have a random number. Random equals new random. So we do 10 times. So what we do is that we're trying to 10 times and get a random index from left to right. And that is we randomly pick a number from the range left to right. So what do we do is that int I equals 0, I smaller than 10, I plus plus. Then what we do is that we have an index equals left plus this random next int. So will be right minus left plus one, right? So that is we randomly pick an index from left to right. So we know for this kind of number we have the list of indexes in the array, right? So that will be we call list equals map get index array index. So we know, of course, the index will be one of the entries of this list, right? But there are some others. So what we do is that this list actually it will not be empty, right? Because it at least have the index as one of the value. So what we do is that we're going to have int count equals we're going to write a binary search. Binary search the list from right plus one minus binary search left. So in the list, what it store is the indexes. So and also the list we'll see the indexes they are in order, right? So so it will return in the list so this one will be the count of this array index, right? So we'll say if this count is greater equal to threshold, we just return array index. And if we do 10 times, right, we're still not final one, we just return -1, right? So that means that we'll have 2 to the power 10th chance to get the result. So if you are very unlucky, that is, you have 2 to the power minus power 10 chance that this test case will be failed, right? But this one here, the binary search, right? For Java, we can write the binary search. Binary search is find index is greater equal to target. So let's write this binary search into binary search list integer. This is the index, right? Integer list and into target. So let's say int start equals to 0 and equals to list dot size -1. Okay, let's put the start in all in the index. Okay? So while start plus one smaller than n, then we'll have intermediate equals start plus n minus start divided by 2, right? So what we do is that if this get mid is already greater equal than target, right? That means we need to find on its left, then we'll have end equals mid. Else we'll have start. We need to find on its right, right? Equals mid. So in the end, what we say, if this get start greater equal to target, right? We just return start, right? And we want to find the first one, right? So we first check start, and the thing is that we also need to check end because it's possible the end, and both end and start does not greater than target, right? All of that smaller than target. So but the thing is that if we didn't find one, what we return is the list dot size. Yeah. Because we want to have this kind of formula to be counts to be satisfied, right? So let's okay. So doing like this, right? So for example, we'll say averagely the list size for it is k, right? So the time complexity will be only be 10 log k for the time complexity. Uh, let's also write a Python code. Python code will be very similar. We have set self dot array equals array self dot map equals default list. So for I num in enumerate array, right? Then we'll have self dot map num append I. Then for the query is for we do 10 times, right? For in range 10. If you are not confident with 10, right? You possibly can get 100. It will be definitely very high chances, right? Possibly 2 to the power 100 chance. So index will be random int left, right. So num will be self dot array index. So what we do is that if num not in map, so this is not possible, right? So we'll say we'll have indexes equals self dot map no. Then we have count equals. Of course, you can use right binary search like the Java, right? But in Python, you can use bisect right. This is right minus bisect left. This is left. So we'll say if count is greater equal to threshold, then return number. So if for after 10 times we didn't find a number, that's a return -1, right? So this kind of question is sub method is efficient. We call random sampling or Monte Carlo simulations.